All right, good morning or afternoon, depending on what hour you've got this class. I bet you thought you were getting out of math today when you saw I wasn't here. Sorry, guys. We're going to have a good time here. All right, real quick, in all seriousness, real quick, get out the worksheet from yesterday. We did the front, the note sheet. We did the front. Now we're going to do the back real quick. All right? So I'll give you a second here to take that out. It looks like this. I have no idea if you can see that. The back, okay? Yesterday we found theta from memory. Today we're going to find theta with a calculator, okay? We're going to find it with a calculator. All right, and I explained there that we've talked about theta. We've talked about many trig ratios like this, like that one problem, sine of theta equals 3/5, where cosine of theta was greater than 0. So we learned that we were in the first quadrant. We drew that 3, 4, 5 triangle. You found all the ratios. Now today, what we're going to do is we're going to actually find that theta. All right? So what I want you to do is get out your calculators, because you're going to need those, and turn to that sheet. 3a is going to be sine of theta equals 3/5. While you're getting that out, I'm going to get some brand new markers here. Sine of theta equals 3/5. Now, if you read the directions, it says we're going to assume that theta is between 0 and 90 degrees or between 0 and pi over 2. So we're going to be in the first quadrant. So we're not worried about any quadrants, okay? Sine's positive, we're going to be in the first quadrant. Now yesterday the key was to find that reference angle. And we did it from memory yesterday. So here's how you're going to do it with your calculator. You're going to have to find the reference angle, and this is up in the top of the notes. You're going to take whatever trig function you're going to have. You're going to take trig inverse, so in this case it's going to be sine inverse of the absolute value of your ratio. And that's going to equal theta prime. Okay? So in this example, theta prime will equal sine inverse of the absolute value of 3/5. See, we don't know. We've had this angle a lot. We've had this triangle. You know, 3, 4, 5, theta, 3, 4, 5, but we don't know that theta, and it hasn't mattered. Okay? Now we're going to find that theta. Now we know we're in the first quadrant, all right? The absolute value on this problem doesn't really matter. All the absolute values does is says ignore the negative. And I'll explain in a couple weeks why we really have to do that absolute value. So, second sine or sine inverse of 3 divided by 5 equals. Now, I have my calculator in degrees because I think it's always easier to find degrees first. Okay? So that theta prime, which since we're in the first quadrant, is theta, is approximately 36.870 degrees once we round up. Since we're in the first quadrant, theta prime and theta are the same. So theta equals 36.870 degrees. Now, if you want to change your calculator to mode radians and punch it in, it'll give you the radian back. So whatever your calculator's in, if your calculator's in degree, it'll give you degree back. If it's in radians, it'll give you radians back. I don't mess with changing. I just do the conversion. So I take 36.870, or this answer that I have, and I multiply it by pi and divide it by 180. And I just get the calculator answer, the numerical answer, and that's approximately 0.644 radians. Make that a little bigger for you. Okay? So, I just did the conversion. Multiply by pi, divide by 180. Okay? Are there any questions? If there are, you better ask your neighbor, because I'm obviously not here. Okay. I'm going to skip to C. Okay, I'm going to skip to C. All right. Cosecant of theta equals 13 over 12. Obviously, we don't care about that. Cosecant we don't have cosecant inverse. So what this means to us is that sine of theta is equal to 12 over 13. So to find theta prime, we're going to do sine inverse of 12 over 13. I've got my calculator in degree mode because I want a degree. So here we go. Sine inverse of 12 divided by 13 equals. And that's going to be approximately 67.380 degrees. So since we're in quadrant 1, theta prime equals theta. So theta is approximately 67.380 degrees. And then I will also find the radian format. I'm just going to right now, just take what I got on the calculator, multiply it by pi, and divide it by 180. And that's going to be about 1.176 radians. Okay? That's showing up all right. Last one might have gotten cut off a little bit. But that's it for those two. Okay, let's go down to number 4. All right, now, let me erase this. 4a. Okay, cosine of theta is equal to 3/4. Now, if you read the directions, it says theta can be anywhere between 0 and 360, so that means we're going to go one time around the circle, just like we did yesterday, except the only difference is we don't know this theta from memory. All the ones yesterday you knew from memory. So what we're going to do is we are going to find the reference angle. That's the first thing we found yesterday. We did it with memory. Theta prime equals cosine inverse of the absolute value of 3/4. Okay? So theta prime is going to be approximately, and I'm going to do this in degrees and I'll convert all my answers to radians at the end. So second cosine of the absolute value of 3/4. I didn't mention this earlier. If it's positive, I don't need the absolute value. Or if it's negative, I'm just going to ignore the negative. That's all the absolute value does. Okay? And that's going to give me 41.410 degrees. 41.410 degrees after we round. Now, I'm not just in the first quadrant. I'm going all the way around the circle. So yesterday we figured out our reference angle. We figured out our quadrant. So this looks to be in quadrants. Cosine is positive. All and consumer. All students take consumer. Quadrants 1 and 4. Okay, so then we draw the picture like we did yesterday. We draw a 41.40 degree angle in quadrant 1. We draw a 41.40 angle in quadrant 4. Okay, so our theta, if we're 41.40 in quadrant 1, that's 41.40 degrees. And if we're 41.40 degrees in quadrant 4, we're going to go all the way around until we get to here. That's 3. We tried to get all the way around to 360, but we stopped shy. So that's 360 minus 41.40, and that's going to give us 318.60 degrees. Okay, that's what I got when I rounded to 3 decimals. Oh, I guess that was 410. Whoops. Sorry about that. And 318 point. It's going to end up being 590 now. Okay. Now all I'm going to do to find the radian is do our conversion. So I'm going to take 41.410 and multiply it by pi and divide it by 360 or 180. Okay, and that's going to be 0.723. And I'm going to take the 318.590 and multiply it by pi and divide it by 180. And that's going to be 5.0 0.560 radians. Okay. I know that those degrees are a little blurry there, but those were both 41.410. That was the reference angle. Okay, 41.410. All right, let's just look at one more. Let's look at C. Okay, in letter C, cotangent of theta equals negative 5.9. Okay, that's the ratio, negative 5.9. We're looking for the theta. All right, now obviously we don't have cotangent inverse. So we're going to change this to tangent inverse, or tangent of theta, equals 1 over negative 5.9. Okay, we've learned all the time, if you know cotangent, tangent is its inverse. All right, make sure that's on the screen. Okay, good. Okay, so theta prime is going to equal tangent inverse of the absolute value of 1 over negative 5.9. So all the absolute value does is makes us positive. So when I punch this in, second tangent, tangent inverse, I'm just going to ignore the negative. 1 divided by 5.9. And I get, it's a very small degree, 9.6197, so it's going to round to 20 degrees. Make sure I don't mess this one up here. 9.620 degrees. That's the reference angle. Quadrants for tangent to be negative. Tangent is negative. Cotangent's negative. Tangent is not negative in the first quadrant because they're all positive. It is negative in the second. It's not negative in the third because that's where we take. And in the fourth, it is negative. Okay? So, go ahead and draw your circle. Draw a 9.620 degree angle in quadrant 2, and draw a 9.62 degree angle in quadrant 4. And then you just have to figure theta. So to get to theta, what I tried to do is go to 180, but I stopped short by 9.620. So one of the answers is 180 minus 9.620. So one of the thetas is approximately 170.38 degrees. And the other one, I tried to get all the way to 360, but I stopped short by that same much. So that's 360 minus 9.620 degrees. So that's 350.38 degrees. Okay? So 180 minus this, 360 minus this. And then to find those in radians, I'll just multiply both of those by pi and divide by 180. So that's going to be 2.73 or 2.973, 974 I should say, rounds up. And I'm going to take 350.38, multiply it by pi, and divide by 180. That's going to be 6.115 radians. Okay? All right. Now, one last thing that I want to do. If you take out the unit circle practice assignment that I gave you last night, okay, where you had all this cosine of 150 degrees. That was the first problem that we did in class, but you had a bunch of those last night. On the back, there was the ratio problem on the bottom. Go ahead and take that worksheet out. just giving you extra time here. It's not that I can't find it. I'm just giving you some extra time for you to find yours right. Okay, keep looking. Okay, hold on. Hold on. Well, I cannot find it. So I'm gonna do a similar example. I kind of remember what it was. All right. On the back of all the unit circle practices that we've had, remember I've given you problems like, okay, cosine, let's do this. Cosine of theta equals -2/3, okay? And tangent of theta is greater than 0. And you found, you went through and you said, okay, I'm going to draw this. Okay, I'm going to figure that I'm in quadrant 4, or in quadrant, cosine is negative, tangent is positive, so I'm in quadrant 3. Okay, my adjacent over my hypotenuse is in a ratio of 2 to 3. So we draw the theta to take us to quadrant 3. Okay, we draw that theta, we draw the triangle. This is going to be -2, this is going to be +3. Adjacent, hypotenuse, right triangle. Okay, you've done that a lot. I don't know if the one I gave you was in this quadrant or not, but this is a similar example. Now, this right here in the purple is theta prime. I've asked you at every one to find theta, and I've told you every night to wait. You can't find it yet. So now I know I'm in quadrant 3. I can find theta prime. Theta prime is going to equal cosine inverse. Okay, here we go. Cosine inverse of the absolute value of -2/3. All right, now, that's going to be theta prime. So go ahead. Whenever you use the cosine inverse, you're finding an angle. All right, so we'll do second cosine. The absolute value is going to make this positive, and we do 2/3. So this angle, theta prime, is 48.18. Geez, these are all rounded up. 0.190 degrees. 48.190 degrees. Okay, that's theta prime. So to find theta, this was in quadrant 3. Here's theta prime right here, 48.190. So what did we do? We went to 180, and then we added 48.190. So 180 plus 48.190 is 228.190 degrees. All right, so now, tonight, you're going to get an extra unit circle extra practice 4 on the back. I want you to work on finding that theta. You're going to have to do that on the quiz on Thursday. Okay, so tonight, your homework, you're going to get the unit circle extra practice 4 chart. Make sure you are doing that. Also, you are going to get, also from the worksheet from last night, finding the theta where you did the front. I want you to do the back. All right, have a great night.